Hello. So here we go. Week 10. First video lecture. Hopefully no one gets hurt. And I did wash my hands before I made this video. So today's weekly agenda for this week. I'm going to be watching these videos. I'm going to send you the link on YouTube, and they'll be titled Week 10 Part 1, Part 2, and if we need Part 3. Remember, the videos can only be 10 minutes in length. Alright, so a little hint, by the way, as someone who has taken video lectures before, when you're watching these on YouTube, you can actually speed up, pause, or even slow down my voice, so have fun with that. And if you notice any issues or bloopers or something you had trouble with, just send me an email. But remember that by Thursday, next Thursday the 26th, you should have watched these videos for the lecture, which will help you take the Kahoot challenge, so do that, make sure that's done. Make sure that you watch the documentary and do the assignment, the film reflection. You have your taste test discussion, the first part due by Sunday, and your response to someone else's post by that. And last but not least, the second Letters Decay assignment. Who knows, maybe I'll actually mail her some if you guys let me. She's got nothing else to do but time and read these. So we're going to talk today about stratospheric ozone. And we talked a little bit before that ozone acts as a sunscreen when it's up in the atmosphere, so it's good for the human race. Whereas when it's down low in the troposphere, where we are, ground level, it's a nasty pollutant, makes asthma worse bad for you. We're going to focus on the ozone in the stratosphere. And ozone is really nothing more than 3 atoms of oxygen bonded together. Now, the thing about oxygen is it likes to stick to other atoms, especially other atoms of oxygen. So you rarely find one atom of oxygen. They're usually bound together in 2 in a molecule. And ozone is actually 3. And how do we get there? Well, ultraviolet radiation hits a bonded pair of oxygen atoms, and the energy in there actually breaks it apart. So now you have these 2 atoms of oxygen floating around up in the atmosphere. But remember, they're kind of sticky. They like to stick to other things, especially other atoms of oxygen. So if they encounter another bonded pair, they stick to it. And that is basically how it's made. And so again, ultraviolet light ultimately creates ozone naturally. And when it degrades, it creates it again. So it's an ongoing natural cycle. And that ozone works to block the worst of the ultraviolet radiation so that we don't all get immediate sunburn, right? Now, what we're going to talk about is one of the issues we had is that man-made pollution was causing ozone to deplenish. And I'll talk about CFCs in a little bit. But the chlorine atom in a CFC molecule, when it encounters oxygen, also likes to stick. In fact, it's actually even stickier than oxygen. So it basically gums up the works, and it stops oxygen from bonding to other oxygen molecules. And so all of a sudden you no longer have any ozone formation going on. But what is a CFC? So CFC is chlorofluorocarbons, and it is a synthetic man-made compound of chlorine, fluorine, and carbon. And we used to use it mainly as refrigerants, but also in aerosol spray cans and in fire extinguishers. So it was actually invented in the 1930s by General Motors and DuPont. And it was originally called Freon, which was one of the first CFC molecules. It's a man-made thing, and it was developed as a refrigerant because before that, the refrigeration molecules we used were actually very, very volatile. And if your refrigerator had a slow leak and there was a small spark, refrigerators would often explode and kill people. So, yay for less exploding fridges, but it also allowed them to put air conditioners in cars for the first time, which is why General Motors was part of it. Okay? So that was the main chemical used to run refrigerators, but in the 1970s, a scientist did a paper and he realized that the CFCs leak from refrigerations and air conditioners over time, and they actually get up into the atmosphere, which is kind of buried here under my shoulder. Okay? And when they get up in the troposphere, they finally go up to the stratosphere. They can linger there for decades, for a long time. And the big problem, as we talked about, is that the C, or the chlorine in the CFCs, causes ozone to stop being replenished. In other words, it destroys the formation of ozone. Okay? And then scientists later did find that the ozone had thinned, especially over Antarctica, mainly because over the poles the air is much colder, there's less clouds, and there's less circulation, so there's less chance to move this ozone-free air. And it actually looks like this. You can see how the blue is lower ozone, this big, huge gap. Now, the reason this took a long time to notice was, honestly, no one lives down here, so nobody was getting sunburns, just the penguins, and they weren't saying much. But it was getting bigger and bigger. So what happens if we don't have an ozonosphere? Well, without that, there would be no life on land at all, just because, one, without that blocking of the ultraviolet light, there'd be issues of skin cancer, that makes your immune system function less, cataracts. It eventually causes plants and animals to stop being able to grow. Okay, so we would actually have a collapse of the ecosystem. In fact, if we had never had an ozonosphere, odds are life might have even evolved. So, in 1989, an international climate change treaty designed to ban CFCs went into effect. So there actually have been successful international climate-related treaties before. And this went into effect in 1989, and you all probably don't remember this, but before then, you used to be able to buy deodorant in a spray can. And if we were in class, I would make the gesture and ask how many of you have done this, and most of you probably use roll. But that was actually one of the side effects. Without CFCs, we could not really use spray cans like we used to, because CFCs were a driver. And as we mentioned before, we now do have other chemicals to use for refrigeration, HFCs. That's a whole different story. But what happens is, this climate change treaty goes into effect in 1989. We stop seeing chlorine in the atmosphere, and it declines. And as it declines, the natural action of the sun and ultraviolet radiation creates more and more ozone. So the ozone holes are actually shrinking. Okay? In other words, left to itself, unless we do something else really, really stupid, the ozone hole will repair itself. And you can see right here, this graph, that the amount of chlorine in the atmosphere rose and rose, and it finally peaked. And predictions show that by roughly the year 2030, we should be back to what we were in the 80s. So it is a naturally occurring phenomenon, and there is one success story with climate change. So this would be the time in class where we normally say take a break, relax. And what I'm going to do here is I'm going to pause the video here and start the next one. So just go back to whatever you're doing, and we'll start the next lecture in just a little bit.